Okay, let me try this again. And I am pulling up. These are the text boxes that I pulled up for 9.1 through 9.3. These are just a few. So you might want to write them down or look them up in your book so you'll have them. This little formula right here is P hat. That's called P hat. Confidence interval versus level of confidence. This is a confidence table. Margin of error and sample size needed. These are the formulas you're going to be using in 9.1 through 9.3. Okay, so I'm going to let you write those down and let you look for them in your book. And then I'll cover the next section, which is 10. Now, the reason I'm not going into any problems is I'm going to be doing problems tomorrow, which is Tuesday, the 19th. I'm going to be going into some problems tomorrow. I usually cover this section very basic. I don't cover a lot of problems because you hardly ever see this. Unless you're going into a second statistics course, you're not going to see it. So I cover some of the basics in 9.1 through 9.3 and 10.1 and 10.3, and that's about as far as I go. So as long as you can plug and chug into these formulas, you'll be okay. Make sure you understand how to use, make sure you understand how to use this formula, because that formula, you'll see it a good bit on the test. And you might see one of these. Now, the difference in these two is that one is when you have, and let me explain something else. I don't like the way this book does. Most books do P and Q. Q is the complement of P, P is the complement of Q. So if P is equal to 0.35, then Q is equal to 0.65. All right, I do not like the way this book writes Q. It writes 1 minus P, and that does more confusion more than anything. So when you see this 1 minus P right here, that's just Q. So if you have a P equal to 70, then Q is equal to 30. Okay, if you have a P is equal to 0.6, then Q is equal to 0.4. All right, that's all it is. So if you want to take this out, that 1 minus P, and just put Q, then your margin of error is equal to a z-score, alpha over 2, times the square root of PQ over N, and that's all it is. So we're not going to use 1 minus P. We're going to use Q. Okay? So when we're using tomorrow in class, when I start the video, we're going to go with the assumption of Q, not 1 minus P. All right? So that's one thing to get before you start doing any of these problems. Something else we're going to talk about is, let me erase this because I don't want to cover that yet.
Priority 1 message coming in on secured channel.
Is this down here. And of course, I'm going to blow it up a little bit so you can actually see it a little bit better. I'll just cover up the others and blow it up. I don't know if it'll show it too good or not. That's these right here. A two-tailed test, a left-tailed test, and a right-tailed test. All right. Now what I'm going to do, I'll tell you what I'll do. I'll make this small again. And for those of you that need to know what's on this one, I just got rid of something. I don't know what I got rid of, but that's great. I'm still getting used to my new toy, so y'all just bear with me. There it is. Make sure you get testing hypothesis regarding a population mean, students T distribution, and testing hypothesis regarding a population proportion P. That's coming out of 10.1 and 10.2, I believe. Yeah, I think. Or 10.3, 10.1 through 10.3. So grab these boxes, copy them out of your, or mark them in your book. I'm going to go right over here and I'm going to pull up give me a second. I'll try to pull this up so you can see it a little bit better. There we go. Now, when you have a two-tailed test, usually you have a two-tailed test when you see the not equals. Now, the not equals and the less than and the greater than are based on reading. Okay, so the not equal, the less than, and the greater than, these are what you call the alternative hypothesis. Okay, these are alternatives. If you have a greater than in your sentence or a more than in your sentence, then it's going to be this one right here. It's a right tail. If you have a less than or a be less than, then that'd be that one right there. If you don't have less than or greater than in your reading, when you're reading the problem, if you don't have these two guys right here, if you don't have less than or greater than, then most of the time, if it's not listed, it's going to be not equal to. So with your alternative hypothesis, you're either going to have an equal sign with a slash through it, meaning not equal. You're going to have a less than, or you're going to have a greater than. Now, the good thing is your alternative hypothesis, your null hypothesis, is always going to be the same. I'm just going to put HYP, okay? It's always going to be equals. Okay, so these are your null hypothesis. I'm getting used to this thing. I'm still not used to it, but it's better than a mouse. Oops. Okay, these guys right here. I'm going to take my highlighter. Maybe the highlighter will do better. There. Your null hypothesis really doesn't change, whether it's a right tail test, a two tail test, or a right tail or left tail test. Now, if you have a non-equal, that's going to be two tails. So non-equal will be a two tail test. Let me just go up here. Okay, this thing is not being there. When you see not equal, then you have a two-tailed test. That means you got a tail here and a tail here, and your area is there, and your area is there. That's not equal. If you have a less than, then that means you've got a left-tailed test, which means on one side, and it's just that area right there. If you have a greater than, then you've got it on the right side. You'll have to excuse me. I'm getting used to this new pad that I've got. Okay, now the only thing you have to remember is when you're doing a two-tailed test, that's your alpha divided by 2. So when you're doing a two-tailed test, and I'll explain alpha in just a minute, alpha is going to be divided by 2. So you need to make that note. This is important because that's important. If you're dealing with a two-tailed test, your area is divided by what? 2, because you got 2 tails. These, you don't have to worry about it because it's only one area. Alright, so let me take my handy dandy highlighter. Well, I can't, it's blue, you're not going to be able to see it. Let me go over it one more time on a clean sheet of paper. For equal sign, not equal sign, that's a two-tailed test. And that area is divided by 2 because you got two sides. That side and that side. And what you need to remember about that is alpha is going to be divided by 2. Less than is going to give you a left side or a left tail test, which is this area right there. And then greater than is going to be a right tail test, which is this area over here. And again, you don't have to worry about the area being divided by anything on these two because this area is that and this area is that. This area is divided by 2, which means you have to take alpha and divide it by 2. Now, what's alpha? Well, alpha is the area that they're giving you in the problem. Okay, remember in chapter 6, I think it's in chapter 6, which I can't remember, chapter 6 or chapter 7, I told you that, hold on a second. I told you in chapter 6 or 7 I told you that area, probability, percentage, they all meant what? The same thing. The area under the what? Under the curve. So all of these area under curve. So all of these names, whether they represent the same thing, the area under the curve. In this section, chapters 9 and 10, instead of calling it area, probability, and percentage, we're just going to stick with the word area, and we're going to call it alpha. Alpha area. So if alpha is equal to 0.05, that means you're looking for an area of 0.0500. The reason I put 4 digits is so you'll know that it's an area. Okay. If I give you alpha is equal to 0.01, then that means the area is 0.0100. Now, what if you have a two-tailed test? You have a two-tailed test, and your area is equal to, I'm just going to do something simple, 0.04. Well, if you're doing a two-tailed test, which means that in the problem you're going to have a not equals, that means that you're going to take alpha and divide it by 2, which each area is 0.02. Half of 4 cents is 2 cents. So alpha over 2, you're going to be looking for that number on the table, 0.0200. Now remember, all these are areas. See? They're 4 digits. I made them into 4 digits so you could remember. So if you're given an area, which we are with alpha, that means we've got to find a what? A z-score. All right, so when you see area or you see alpha, chances are the thing that you've got to do next is find a z-score. Okay? Now, this is a kind of an introduction, and tomorrow I will be doing problems in 9.1 through 9.3, and I'll try to get into chapter 10 as soon as I can. Those of you that are ahead, all I can tell you is just be patient. I don't want to teach the same thing over and over, so I'm not going to teach it today in my office and then teach it tomorrow. So I'm going to teach it all at one time. I hope you can respect that. So, and I'm trying to use my new toy too. So maybe that'll help some of you get started on chapter 9 and 10, or chapter 9 at least. Okay?